Welcome to section 5.3, Slope-Intercept Form, the lesson you've been waiting for, or at least me, because I like slope. So let's get started. Let's talk about the objective first. I can write and graph linear equations using slope-intercept form. So, first of all, a family of functions is a group of functions with common characteristics. Just like a family is a group of people that has common characteristics, whether physical or none. Now, a parent function is similar to a parent of a family. It's the leader of the function, and it's the simplest function. So an example of a parent function would be y equals x. Now, a linear equation is an equation that models a linear function. So you want to write this down. When it is linear, the variables cannot be raised to a power other than 1. So here are a few examples and non-examples. A few examples would be y equals 2x, as well as y equals negative 1/2 x. And here are a few non-examples. You do want to write these down. Y equals 2 to the x, and y equals x to the second. And we have taken a look at both of these non-examples in the nonlinear function section 4.3. The y-intercept is the y-coordinate of a point where the graph crosses the y-axis. So on this graph at right, the y-intercept is this blue point right here that I am highlighting. It is the point where the graph crosses the y-axis, as well as this line right here would be the origin. That is the y-intercept. So the slope-intercept form that you probably know by heart already, which is awesome, is y equals mx plus b. M stands for the slope and b stands for the y-intercept. We can use the slope and the y-intercept of a line to write and graph an equation of a line. And you do want to fill this in of a non-vertical line. So it can be diagonal, it can be horizontal, anywhere in between, but it cannot be vertical. The reason why is because of a vertical line, the slope is undefined, and we cannot substitute an undefined slope into the equation. We are ready to do example number 1. What is the slope and what is the y-intercept of this graph? Well, we don't need to graph it. All we need to do is write y equals mx plus b directly below. This is your work. And the m and the b are lined up with the numbers up top. So circle them, and we can see that m equals 5. That is the slope. And b equals a negative 2, and that is the y-intercept. And technically the slope is 5 over 1, but we don't need to write that as long as you know that there's a 1 in the denominator. Example 2. What is an equation of a line with slope negative 4/5 and y-intercept 7? Okay, we're using slope-intercept form. And we're given that m equals negative 4/5 and b equals 7. So all you have to do is take those and plug them in. So the negative 4/5 goes where the m is, and the 7 goes where the b is. So our equation in slope-intercept form is y equals negative 4/5 x plus 7. That completes example 2, and we're ready to move on to example 3. Which equation represents the line shown? Well, what I would do is identify what the slope and the y-intercept are. So you can either identify the slope by just looking at the graph or actually use the slope formula, y2 minus y1 over x2 minus x1. It's your choice. I'll show you both ways. Taking a look at the graph first, rise over run. So you start at the left point and you go up 2 units and over 1. So the slope is 2 over 1. Another way to do this coordinate point is 1, 0, and this coordinate point is 0, negative 2. So let's plug those in, x1, y1, x2, y2. We're going to have negative 2 minus 0, and 0 minus 1. That leaves us with negative 2 over negative 1, and that means positive 2 over 1. So the slope is 2. Now the y-intercept, hopefully we can realize that that is the point right here where the graph crosses the y-axis. So that means our b value is -2. Let's put that together. Y equals mx plus b. The 2 goes where the m is, and the -2 goes where the b is. So our answer is y equals 2x minus 2, and that is option D. Feel free to pause here if you need to catch up. We're going to keep rolling. Example 4, writing an equation from 2 points. The first thing that we want to do is use the 2 points to find the slope. So we're going to have this first point be x1, y1, and the second point be x2, y2. Now we're going to use the slope formula. Slope equals m, which equals y2 minus y1 over x2 minus x1. And now we're going to substitute in. So we have -8 minus 1 over 5 minus 2. When we simplify, we have -9 on top and 3 on bottom, and that reduces to -3. So our slope is -3. After that, we just found the slope. We need to use the slope and the coordinates of one of the points to find the y-intercept. So first of all, let's see, we want to use y equals mx plus b. We can put the -3 where the m is and bring down the rest. And now, which coordinate looks easier to work with, 2, 1, or 5, -8? Personally, I think 2, 1 is easier, so let's plug that point in. We're taking the 2 and we're plugging it in where the x is. The b stays the same, that's what we're solving for, and the 1 goes where the y is. Now you bring down the 1, that is a -6 and a plus b. Now you're going to have to add 6, that's the opposite operation, and you get 7 is equal to b. So now all you have to do is take the 7 and plug it in where the b is, right there. So our answer is going to be y equals -3x plus 7. So let me just recap. Step 1 was to find the slope. Step 2 was to find the y-intercept, and the way that we did that was plug in the slope and plug in the easier point of the 2 and find the b. And the last step is just plug in the m and the b for the slope-intercept form and call it done. Example 5. We can use the slope and the y-intercept from an equation to graph a line. So the blanks here are slope, y-intercept, and we'll use both of those to graph a line. So take a look. We have 2 examples here. First one is y equals 2x minus 1. So what we want to do is identify what the slope and the y-intercept are. Here's the slope, and here's the y-intercept. So we have m equals 2, technically over 1, and b equals 1. You always want to start graphing by plotting the y-intercept. So plot y-intercept. That is the first step. So please just make sure you put the -1, the negative sign in front of the 1, and that means the y-intercept is -1. So please fix that. I apologize for that mistake. Now, if we have the y-intercept plotted, we're going to use the slope now. So start at the y-intercept, put your cursor there, and you're going to go up 2 units, 1, 2, and over 1. So up 2, over 1, up 2, over 1, up 2, over 1, etc. And if you wanted to go in the opposite direction, it would be down 2, over 1, like this. And you want to connect those and put arrows at the end to show that it's continuing. Alright, that graph is done. Now, on the other side, we have y equals -3x plus 4. The slope is -3, technically over 1, and the y-intercept is 4. So again, first step is to plot the y-intercept, which is +4. Now, for the slope, it's -3 over 1. That means instead of going up 3, we're going down 3. So we have that point plotted. We went down 3 over 1, down 3 over 1. It keeps going. Down 3 over 1. And you can connect. As you can see, the graph on the left side is a positive slope, so it's slanting up, and the graph on the right side is a negative slope and it's slanting down. So you will always see the difference between the two when you have a positive slope and a negative slope. That completes lesson 5.2. Please feel free to go back and catch up if you need to. Make sure you have done 5.2 lesson check and feel free to start 5.3.